And we think our signal is through now. It looks like the crew is ready. Commander MICHAEL Lopez-ALEGRIA is standing by in the Destiny laboratory aboard the International Space Station to bring us the first ever live downlink from space in HD. Mike, can you hear me out there?
I hear you loud and clear, Robert. How do you hear me?
Okay, I hear you very well, and we'll explain to our viewing audience that because the distances involved here, they're 215 miles away, so there's just a little delay in the back and forth. Mike, show us what you can. You're in the Destiny laboratory there, right? Can you take us on a little tour of what it looks like?
You bet. This is actually the Unity node, which is attached to the Destiny laboratory. We'll be going there in just a second. But this is one of about 6 habitable volumes that we have on board the space station. My crew of 3, Thomas Reiter from the European Space Agency, who is behind the camera, so you can't see him, and Michael Turin, a cosmonaut from the Russian Space Agency. And I have been aboard for about 2 months or so. Actually, Thomas has been here a bit longer. And we basically spend most of our time doing experiments, operating, maintaining, and constructing it sometimes this space station. So let me start with a little bit of a tour. As I said, this is a node. It has 6 different ports to which other modules can be attached. We also use it mostly for storage. Here you see a couple of spacesuits that we use for EVAs, extravehicular activities, or spacewalks. This is a Russian version on your left and a US version on the right. And this is what we affectionately call the water wall. There are a whole bunch of these collapsible water containers behind them, which you see right here. Water, of course, is very precious to us, as it is to everybody on the ground. We use it not only for food and cooking, drinking, and hygiene, but we also use it to generate oxygen. So as you can see, it's sort of a very important consumable for us. And then above me, on what would be the ceiling, is our resistive exercise device, which is also sort of like a universal weight machine. And we use this as one of our exercise tools to keep us in good shape. I'll see if I can demonstrate here one of the exercises we might want to do. Of course, the loss of bone and muscle density in space is a very important consideration, so we have a couple of countermeasures we use to try to avoid that loss. See if I can do a couple bench press repetitions here. The resistance, of course, we can adjust with these cans, which basically it's just a great big rubber band that keeps the resistance wherever we need it. Actually very effective. Okay, we're going to head forward now from the Unity into the laboratory module. As you mentioned, the lab module is called Destiny. And this is where we do the bulk of our work here on the US segment. We have a number of experiments that are going on in here all the time. We do some operations from here, and I actually live here right now. Thomas and Misha live in the Russian segment in the service module. First stop here is our robotic workstation. We use this to control the space station's robotic manipulator system, otherwise known as the robot arm. You can see a couple of hand controllers, some monitors that we use to view our work as it's going on. Continuing forward, you see we have a lot of these laptops deployed. We actually control the station largely through laptops when we do it on board, although our team in Mission Control in Houston does most of that commanding. Here are a couple of experiments. One in particular is pretty interesting. This European delivered MELFI, which stands for minus 80 degree laboratory freezer. It's in fact closer to minus 100 degrees right now, and I thought I might show you where we like to keep our ice cream if we had any on board.
Mike, that's a new piece of equipment up there, right?
Mike, that's a new piece of equipment up there, right?
Yes, MELFI came up about 2 shuttle flights ago, and we're already using it to store samples of blood and urine that we're collecting for some experiments as well as some others. I'll give you a peek inside here. In case you can't tell on high definition, which I'm sure you can, it's quite cold.
How cold again was it, Mike?
In fact, it's frozen, it appears.
How cold again was it, Mike?
It's about a minus 100 degrees centigrade. So it's quite cold.
Yeah, I would not want to go out in that. But the fact that you got that freezer up there now enables you to store samples of your own blood for blood checks later, right? For determining bodily changes as you stay on the space station over a longer time?
Right. One of the things that we're very interested in, of course, is what happens to the human body as we are subjected to long periods of microgravity. And we can measure what we intake by basically notating everything that we eat or drink in a certain period, and then our blood samples correlate how our body is processing those. And of course, the blood samples we can't analyze on board, so we freeze them for later analysis on the ground.
How about the rest of the experiments?
Okay, right above me now is the European Modular Cultivation System. It's basically a couple of large centrifuge tables which can hold some biological samples, either plants or other tissues, that we can vary the effects of gravity by spinning them at various rates. There's all kinds of photographic and other recording equipment inside that can monitor what's going on with those samples as we use them. Immediately to your left is one of our 2 human research facility racks. There's equipment to measure gas intake. We use that a lot when we're doing exercise to try to understand how our bodies are processing, metabolizing oxygen, especially on board. I'm passing over one of our favorite spots in the laboratory, which is the window, which looks down over the Earth. We'll probably take a look at that a bit later.
Oh, you bet. We're planning on that.
Your left, again, is the CVIS, the cycle ergometer vibration isolation system. You see it appears to be floating. It's actually on a series of well, vibration isolators, so that our loads that we put in when we're pedaling don't get transmitted to the structure and disturb the microgravity environment aboard the station. On the left, excuse me, on your right, behind that other laptop is a microgravity science glove box that we can use. We would put our arms inside those 2, well, you can only see one of them, green circles there, to be able to work in an environment that might be hazardous to us, or in other way want to be protected from aboard. This is a very forwardmost part of the node. All this gear that you see here is stuff that has been pre-packed. It will be going home on the shuttle Discovery, which we expect in early December. And a couple of more experiments. This is called Alta, the anomalous long-term effects on astronauts. This is basically a measurement tool to measure, I'll just call them cosmic rays, that we take on board. We actually put this EEG cap on and put our head inside this device, and we can correlate. Actually, there's some visual disturbances that occur, and we can correlate when they occur to when these sensitive sensors can measure impacts from cosmic energy. Lastly, this experiment is called Spheres, synchronized position hold. Let's see if I can get the rest of the acronym. I can't.